I'll start chapter 1. In this chapter, we'll understand linear expression as an equation and a function, and use the understanding of equation and functions to solve simultaneous equations. Before starting this chapter, we'll learn about a few terms about this linear expressions. Here's the linear expression that y equals mx plus c. Right here, we call this slope. And this constant right here, the c, we call this the y-intercept. Like this, using equation, we can have the slope and y-intercept. And then, this time I'll draw this graph. So, in this picture, there are two graphs, graph A and B. And when you look at graph A, the point that touches x right here, this is minus 2. This is the x-intercept. The point that touches the y-axis right this point here, this is the y-intercept. And again, let's look at the graph B. In the graph B, this point right here, this is x-intercept. And again, this part right here is a y-intercept. Like this. Instead of looking at the equation, we can look at the graph also to find the slope. So to check the slope, so we should draw a little triangle right here. And this triangle is a triangle that connects the x-intercept and y-intercept. And then when I look at here, the x moved by 2 in this triangle. And the y moved by 1 in this triangle. So the slope of this graph is 1 over 2 or half. Now let's look at b. The x changed by 4. And the y changed by 3. So the slope is 3 over 4 or 3/4. And some people will be confused. Why are the minuses not included in the fraction or the slope? So when you look at the graph, you should always look at the right top. If the right side is heading to the top, then it's always plus the slope. But if it's heading to right down, it's always a minus. And here's one more picture of graph C and D. And in graph C, x-intercept minus 2, y-intercept minus 1. In D, x positive 4 and y positive 3. And let's find out the slope. Both C and D, when you look at the right, and they're heading to the downside. So the slopes are both minus for these graphs. And also, that exchange is 2. Before that, we start triangle. So that exchange by 2. The y change 1. The slope of C is minus 1 over 2. And now let's look at D. So minus, and then x change by 4 right here. Y change by 3 right here. So the slope is minus 3/4. Like this, we can know the slope instead of looking at the equation, but looking at the graph. So in this graph, we can learn the slopes and y-intercept and x-intercept and many different informations from here. And I'll just add one more thing right here. So the x-intercept, so when you just look at the graph, x-intercept is a point at the x-axis and both at the graph. So when you look at this point, it's 4, 0. And when we look at this point, it's minus 2, 0. And right here at C, it's minus 2, 0, and D, it's 4, 0. So you can see something common right here. The x-intercept is a point that y is 0. So now let's look at the y-intercept. Right here, it's 0, 1. And this point is 0, minus 3, 0, minus 1, and 0, 3. Also, you can see that all the x is 0. So the y-intercept is a point that x is 0. Like this, we learn these things, how to find out x-intercept and y-intercept. And let's just try one more example. Y equals 2x plus 3. So we can know slope, which is 2, and the y-intercept, which is 3, and the x-intercept. Also, some people will say that I don't know how to do this, but just think about it. X-intercept was the point that y equals 0. So if we just change those y right there to 0, that will be the x-intercept. Then 0 equals 2x plus 3, minus 3 equals 2x, and dividing both sides with 2, then the x equals minus 3 over 2. It's pretty simple. Right here, here's an equation that y equals 2x plus 1. it's a linear expression, and I'll just modify this x to change the output, which is a y. So when the x is 1, the y will be 3, x is 2, the y will be 5, and x is 3, the y will be 7. And then like this, we call these variables. So the output is changed when the input is changed. In this case, the y's output and the x's input. So it'll be numbers like x, y, a, b, and also there's a coefficient right here. But to do this, I'll just modify this equation of it. So instead of writing y equals 2x plus 1, we can write 2x minus y plus 1 equals 0. This is basically saying. So you should always be able to change this form of the equation with ease. So right here, it's the same equation, but it's just way easier to look at this. So first, the coefficient is numbers that go in front of variables like x, y, a, and b. So in case of this equation, the coefficient of the x will be 2, and the coefficient of y will be minus 1. And let's just write one more equation down. X plus 5y minus 3 equals 0. So right here, the coefficient of x is 1, coefficient of y is 5, and just always remember that the sign follows it, and there's a constant, so it's a number that isn't related with the variable and exists alone. So in the equation right there will be 1 and minus 3, and finally, there's a point of intersection. Verily, this is a point that two graphs intersect with each other. So here with the graph picture for it. Here's a picture. Right here, here's an x-axis, and here's a y-axis. And there are two graphs going through this graph paper. Right here, this point right here that intersects it, it's a point of intersection. We will learn how to find out this point later in chapter 1, and let's just go over it right now. Until now, we learned a few things from here. The x-intercept, y-intercept, slope. So these were basically used in functions, and 3 ones related to numbers, variable, coefficient, and constant. Coefficient number in front of the variable, constant, the number that isn't related with the variable, and the point of intersection, which is the point that the two graphs intersect with each other. This is question 5, the getting started question. Before solving this question, we should just learn one simple thing. Here's A multiplied by B plus C. One in the front and one in the back, and it will be AB plus AC. And one more. Here's minus A multiplied by B minus C. Then it will be one in the front, so it will be minus AB, and one in the back. Minus and minus will be the added output plus AC. Just remembering this question won't be that hard. So x with the x and number of the numbers right here. 5x minus 3x, then it will be 2x. And right here is positive 10, positive 12, then it will be positive 22. And the second one is just one in the front and one in the back, so it will be 12x plus 20. And the third one, here's the minus. One in the front, minus 10x, and one in the back, it will be minus and positive 4. So let's just see right now. So let's just expand out those parentheses. Then 3x minus 6 plus 2x plus 7. And x with the x, it will be 5x. And number of numbers, minus 6, positive 7, that will be positive 1. And this is the fifth one. Let's just expand this down. 6, 1 in the front, 1 in the back, 12x minus 24. And here's a minus right here, so it'll be minus 21x minus 18. Again, next with x, number of the number, 12 minus 20 on minus 9x. And minus 24 negative 18, that will add up to minus 42. And it's a final question. So let's expand the parentheses. 8x minus 14 plus 7x plus 6. Since it's just plus, we can just expand it out easily. And again, then it will be number of the x with the x, number of the number, 15x minus 14 positive 6. Then it will be minus 8. Equation number 5 like this. This is question 6. It's also pretty simple. Here's the one form ax plus by plus c equals 0, and the one other form y equals mx plus c. So we should just change these two forms. Let's start with a, so the 4y stays here, 4y equals 3x minus 6 goes over, minus 3x plus 6. But it's requiring y equals form, not 4y equals 4. We should divide both sides with the coefficient of the y, which is 4. Then it will be 4. Then it will be y equals minus 3 over 4x plus 6 over 4, simplified 3 over 2. And here's c. Right here, they're same form. Then will be, y equals 4 because the y is minus. We'll just make y go over to make the y positive. Then 4x minus 3 equals 7y. And we should divide both sides with the coefficient, which is a 7. And let's write it out. Y equals 4 over 7x minus 3 over 7. And then it's b and d left. So b is also pretty easy. So the y should just go over to make this into ax plus by plus c form. So then it will be 2, 0 equals 2x minus 5. It used to be a plus, and going it will be minus y. But it wanted x, y constant, not x constant y. So we'll just write it one more time. 2x minus y minus 5 equals 0. And now let's hope for the last question, D. So this time the x and constant will go over because those minuses are not that great. And 2 over 3x plus y plus 5 over 6, and this equals 0. Because it requires an integer form, not in fraction, we'll multiply both sides with the code that's least common multiple of 3 and 6, which is 6. And 2 over 3, so multiply by 6, it will be 3 and 6, it will be 2, and it will be 4x plus 6y, and plus 6 and 6 goes over, and that will be 5 equals 0. So let's write that again. 4x plus 6y plus 5 equals 0. So this is the answer. This is question 7. In this question, we should find the slope and y-intercept in each of those linear expressions a, b, c, and d. So, do you remember y equals mx plus c that we just did before? Right here, the m was a slope and the c was a y-intercept. So then let's just write this out. So it's for a, so the slope is 3. In case of b, it's 0.5 or 1 over 2 or half. And c is minus 2 over 3. And lastly for d is 2.6. And for y-intercept, for a is my negative 5. And for b, it will be plus 0 at the behind, so it will be 0. And for c, it's 1. And for d, it's negative 1.2. Before doing that, I'll just explain one more thing for you. So when we just talked about the slope was a plus, it headed to the right top, and when slope was minus, it heads to left and right down. So the slope is, so it'll be and run under the rise. So this means that run is how the x changes, and the rise is how the y changes. So it'll just be a bit complicated if I just explain some words. But let's just draw the graph to make it way easier. So here's a graph paper. Let's start with A. In case of A, the y-intercept was negative 5, so it's here. And then the slope was 3. So the 3 is, when look at this, the 3 is same as 3 over 1. And then the run was how the x changed, so the x moved by 1 block right here. And for the y, it moved by 3 blocks. So it'll be 1, 2, and 3 until this point. And then, connecting these 2 points, this will be the graph of A. So right here, when you look at this, so the slope was positive, so it headed to right top. Also, always remember that. And now let's look at graph B. In graph B, the slope is 1 over 2. And the y-intercept was 0, so right here, So half is x, 2 for the x and 1 for the y. So it's plus and also hit the right top. So write 2 to the x and 1 for the y. And then connecting these two straight right here. This will be the graph of question B. And now there's C. So the slope is minus, so heads are right down. The y-intercept is 1, so it will be right here. It moves 3 for the x. It moves 2 for the y, but because it heads to right down, it'll go down instead. That's 9. And connecting these two lines, this will be the graph for C. And finally, it's graph D. So for the y-intercept is negative 1.2. It's decimal, so it will be about somewhere here. And then we should find the slope of it. So the slope is 2.6, and 2.6 equals 1 under 2.6. So when x moved by 1, the y will move by 2.6, right here in this graph of D. So let's try this out. X moved by 1 block, and then 2.6 moved for y, so it will be about here, right this. And then connecting these two lines, this will be the graph for D. Also, it can always extend behind this, but to make it easier, I'm just not drawing it. Always remember that. And then we can find out the graph for D. Like this, we're able to find the slope and y-intercept from the equation and to draw the graph using that. This is question 8. In the question 8, it asks as graph ABCD in question 7 are direct variations or partial variation. So before doing that, we should know what's direct and what's partial right here. So to do that, we'll draw the graph paper like this. In the linear expression, the direct variation is a graph that touches the 0, 0 right here. So it can look any way. It can look like this, or it can even look like this, just like almost touching the x-axis. Anyway, the direct variation is a graph that touches 0, 0. And partial variation is the exact opposite. It's every other graph that doesn't touch 0, 0. So we call such linear expressions partial variation. And now let's look at question 7. When we just draw the graph in question 7, only B was the only graph that touches 0, 0. So the B is the only direct variation, and other graphs A, C, D are the partial variation. This is question 9. In this question, it shows a graph of Kyle's journey from school to home. So this question asks the distance between home and school. So that's question A. The speed of Kyle for question B. So first, let's find the distance. So when we look at this, that Kyle departed from the school, and he arrived at the home 15 minutes later. And then, so when the time is 0, so then this means that he didn't depart from the school. So then this means, so this is distance from school to home. So when look at this, the distance is in kilometers. So 4 to, and right here will be 5. And then the distance will be 4.5 kilometers. So let's just write that again. Distance from school to home is 4.5 kilometers. And now let's find out the speed of Kyle. So to find the speed, we need to know one formula. So we should just we should just draw one triangle right here, and then divide into 3 parts like this. And right here will be right D, time for T, and speed for S, so we call this DTS. And the distance will be time multiplied by speed. And right here, the time will be, so just think this is a fraction, then it will be D over S. And the S will be also saying this is a fraction, D over T. So you could just find it like this. So to find the speed, you'll always be careful of those units. So kilometer per hour, kilometer per minute, they're all different. So if you just write down wrong units and just calculate it, you'll 100% get wrong answer. So right here, the time is in minutes in this graph, and it's kilometer right here. So I will change this minute to hour because kilometer is normally used with hours. So to do that, we'll just write out the 15 minutes. So this will be 15 over 60, and this will be 1/4 hour. Let's just do one more example right here. So if it's 30 minutes, then it will be 30 over 60, and that will be 1/2 hour. And now let's just calculate this out. So it will be 1/4 hour. The speed was distance over time. Then the speed equals the time, which is 1/4, and the distance, which is 4.5. So this will also be a fraction, that will be 2/9. So to calculate these complex fractions, first we will put those, multiply those inside and go under, multiply those outsides to go over, that will be 36, which is 4 multiplied by 9, and then these two are simplified, then it will be 18 kilometers per hour. This is question 10. In this question, it asks us if there's ABCD is linear or non-linear. So linear means the degree is 1, and right here is a picture about it. So linear is in form of ax plus b. So the x is linear. Its degree is 1. And when the degree is 2, and we call quadratic, and it's in form of x squared plus bx plus c. When I look at this, it was ax squared, so degree 2. Bx, this is linear, and c, this is constant. So even though there's linear, we call this quadratic because we want the biggest ones, the degree 2 right here. And for the degree 3, when there is an ax cubed, it's degree 3, and we call this cubic. And finally, if there's ax 4, then it's degree 4 and name quarter. So this means linear has ax plus b form. So right here, the precondition is that a isn't 0, and the b can be 0, but it doesn't matter if it is not 0. So it actually doesn't matter. And now, let's look at those a, b, c, d to find this out. In case of a, it's 3x minus 6, it's definitely linear. And let's look at c. It has 5x squared, degree 2, so this is a quadratic equation. And this time, let's look at b. It's in form table, and when x changes by 1, 2, 3, 4, 5, 6, y changes by 7, 9, 11, 13, 15, and 17. And I guess I'll solve this one. Right here, let's write it out. X moved by 1, 1, 1. Right here, x changing by 1. I'm gonna look at y, it changed by 2. The y changed by 2. And the y changes by 2. We can check this is a linear. So like this, if the difference is same, this is linear. So y equals 2x plus something. And right here, you should find this something here. So let's just put 1 in the x and 7 in the y. Then 2 multiplied by 1, so this will equal 2. 7 equals 2 plus something, then something will be 5. So the equation for the b is y equals 2x plus 5. Let's just double check this one. If I put 2 in the x, it will be 4 plus 5, and that will equal 9. So it's same. So let's just do one more example about this. The x changed by 1, 1, 2, 3, 4, 5, and y changed by -3, -3, and -3. If you just check the first 3, you can see it if it's linear or quadratic. And then the equation will be y equals -3x plus something again. And we will choose a one pair of number to put at x and y. It doesn't matter if we put 5 and -7, but if the number is smaller, it's simpler to calculate. So 1 in the x and 5 in the y, -3 multiplied by 1, this will equal -3, plus something equals 5, then something will be 8. Right here, the equation for this one is y equals -3x plus 8. And for this, let's just double check it. 2 in the x, -6 plus 8, and this will equal 2. Like this, we can find out that b is linear in this question. And finally, there's one left, which is D. In case of D, the x changes by 1, 1, but the y changes differently. It changed by -3, it changed by -5, it changed by -7, and like this is definitely not nonlinear. And then, I'll also solve this one right now. So right here is a bit complicated, so you should watch this carefully. So x by 1, 1, 1. And the y, when you look at the y, it changed by -3, changed by 5, and changed by 7. Right here, when I look at the first one, if the difference isn't same, then it's always not linear. And let's check the difference of it. This will be 2, and this will be 2. And then, this will be quadratic. So we found out that's quadratic, and then we should bring this to 2 right here, and divide it with 2. It doesn't matter if the number is 4, 5, 6, 7, but you always divide it by 2. Right here, if this is quadratic, divide the difference of the difference by 2 from the start. And then it will be x squared. 2 divided by 2 equals 1, so it will be x squared. And it will be something x plus something. And let's find these out. So right here was an x squared. And we'll bring this x squared right here. And then we'll put 1 in here, which is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, like this. And this will be 1, 4, 9, 16, and 25. And then, like this is -3 right here. So we'll minus that number from there. So it will be -3 minus 1, and there will be -4, like that. And look at this one. It will be 0 minus 4, and that will also equal -4. And now 5 minus 9, and this will also be -4. 12 and 16 minus 4. 21 and 25, this is also -4. And the game was look at the difference between these numbers, 0, 0, and 0. Like this, we can check this something x is 0, so that doesn't exist. And now let's just look at the constant. X squared plus something x, but something was 0, so just constant, so it's left. And this equals y. Right here, we'll just bring one number here. When x is 1, the y is -3. And of course, this constant will be -4. And y equals x squared minus 4. When the x is 2, the y is 0, then 2 squared minus 4, that equals 0. X is 3, 3 squared minus 4, and that equals 5. So the equation is y equals 2x squared minus 4. I'll just do one more of this. Right here is another table. And x changed by 1, 1, 1. And the y changed by 3. It changed by 7. And it changes by 11. 15. And let's just check it again. This will be 4, 4 again, and also 4 again. Like this, we found this out. Right here, we'll bring this one here and divide it with 2 always, then it will be 2. So this equation will start with 2x squared, something x squared plus something x plus something, y equals, but right here, put those 4 divided by 2, we'll put this here, and it will be 2x squared. And I can say, so, okay. And then let's go for the second one. 2, we'll bring the 2x squared here. And then we'll put 1, 2, 3, 4, and 5 into x. Right here, and then we'll calculate it. This will be 2 multiplied by 1 squared, 2 multiplied by 2 squared, 2 multiplied by 3 squared, 2 multiplied by 4 squared, and 2 multiplied by 5 squared. And let's calculate this out. Then this will be 2, this will be 8, this will be 18, and then 32, and finally 50. And again, minus those number from the number up there in the y. This number from this number. And then we'll just do it. 0 minus 2, 3 minus 8, 10 minus 18, 20 minus 22 is 32, and 36 minus 50. Let's write that. That will be -2, -5, -8, -11, and then -14. And then, right now, again, we'll find out the difference between these numbers. -3, -3, -3, and again -3. Then that something at the middle, something x, will be -3x. So we only constant is left. So y equals 2x and -3x plus something. And right here, we'll just grab any number right here. I'll choose 1 and 0. 1, 1, and the y equals 0. So 2x2 minus 3 plus something equals 0. Then that something will be 1. And also this is 1. And let's just double check it. 2 and 3. 2 and 2 squared, that will be 8, minus 3 and 2 minus 6 plus 1, and that equals 3. Like this. By looking at the table, we can find out the quadratic equation of that table. This is question 11. This is pretty simple. We just need to find the yintercept. Let's just solve it quickly. X equals 5 goes over 12 minus 5, and x equals 7. And this time, x will go over 13 will go over. X equals 9 minus 13, which equals -4. And C, dividing both sides with 2, x equals 9. And D, dividing both sides with -3, then x will equal 7. And E, the 5 will go over. 2x equals 20, so dividing both sides with 2 will be x equals 10. And finally, the 7. X goes over 6 goes over. 4x minus 8, x equals plus 2 plus 6. Minus 4x equals 8, then x dividing both sides by -4, then x will equal -2. Like this question 11. This is question 12. In this question, it gives us the x and access to find y of it. Let's start with question A. In A, it says the x is 1.5. Let's just solve it. So 4.5 minus 2y equals 14. 2y will go over and 14 will go over. Then 4.5 minus 14 will equal 2y. Right here, then minus negative 9.5. And 2y here, dividing both sides with 2, it will be y equals 2 under 9.5, and this will equal 4.8. Now negative 4.8. And now let's solve for b right here. So this time it gave us the y, not the x. Let's say the y is 0.7. And before calculating this, I'll just fix this decimal first. 2 before, then I'll multiply hundreds them both sides. Then 36x plus 54y equals 110. This is how I'll solve this question. So then I'll put 0.7 in the y, then it will be 36x plus, and then this will be 37.8, and this equals 110. So 36x equals 110 minus 37.8, and this equals 72.2. And then I'll divide both sides with 36. Then it will be x equals 36 under 72.2. And that equals 2.00555. It will just go like this. So it will just be right here. It'll be 2.01. This is question 13. So it asks us to draw the graph in two ways for the equation 2x minus 1 equals 8, and to say which one is easier. So I'll just draw it with two ways right here. Before doing that, I'll change the equation a bit. 2x minus 8 equals 4y, and dividing both sides with the coefficient, which is 4, to make the y equals form, that will be y equals 1/2 x minus 2. And there's the first way. So for the first one, I'll need the slope of it. So the slope will be 1/2. The y-intercept is also needed, which is -2. And then let's draw this out. So first pointing y-intercept right here, which is -2. And then we'll need the slope. So it was slope was run under rise. So this will be run, and this will be rise. So before doing that, so big slope is a plus, it has to right top. And then it's -2, so 2 blocks to the right and 1 blocks to the top. 2 and 1. So connecting these 2 points, this will be the graph of 413. And we'll solve it with one more way right here. 2. So again, we'll use the equation y equals half x minus 2. And then we only use x-intercept and y-intercept to solve this. So x-intercept, so this was when the y was 0. So we can just get it one by putting 0 in the y. 0 equals half x minus 2. Half x equals 2. Multiplying both sides with 2, it will be, so the x will be 4. And as we have did before, the y-intercept was -2 right here, like this, and we'll use these two to draw. Here's the graph. Y-intercept was -2, and x-intercept was 4. So connecting these two graphs, this will be the graph for 13. So these look a bit different, but they're still the same graph. So for the easier way to solve this, maybe you can just find your own answer. And let's work this for the last question. So we should make $100 with $5 and $10 bills. So in this question, you should always draw the table before drawing the graph. So let's draw the table right now. So we should make $100. So always choose the biggest one first, and then go to the smallest one to solve it easily. So to make $100, we'll use $10, $10, and no $5, $9 $10, and two $5, $8 $10, and four $5, and I'll go on. Right here, let's start with the smallest one. And then this will mean, so $25 and $10, $10, and $5 like this. This will also go on. So this time we'll make the equation about it. For the equation, I'll put $10 as an x and $5 as in y. Right here, it will be 10x plus 5y equals 100. And then, because I should also draw the graph, let's change to y equals 4, while 5y equals minus 10x plus 100. Dividing both sides with 5 will be y equals minus 2x plus 20. And this time, let's draw it with x-intercept and y-intercept. First, we should find the y-intercept, which is 20, just a constant. The x-intercept was when the y was 0, so we should just change the y to 0 to find it out. 0 equals negative 2x plus 20. Negative 20 equals negative 2x. But dividing both sides with negative 2, x will be 10. So this is 10. And let's draw the graph. So right here, so x-intercept is 0, y-intercept is here. And then connecting these two straight, this will be the graph for this question. But you should always remember something, that there can be 1, 2, 3, 4, 5, 10 $10 bills, and 1, 0, 2, 4, 6 $5 bills, but there can be 1.2 $10 bills to 9.75 $5 bills. So then, this should be the broken line like this. Or maybe it could be 2, it could be 3, like this. It will just continue on and on. And like this will create a broken line. But it can't be like the straight line. So we should erase the red line off and create a broken line like this. In this case, so it's not a full line, but it's just a broken line. So you should be careful about that. If you liked the video, please press like and subscribe to the channel. Those likes and subscribes will be very helpful for the channel.